In this lesson, we're going to learn how to solve rational inequalities. Rational functions can change signs at zeros or at points of discontinuity. Therefore, when you're solving a rational inequality, you must include the zeros of the numerator and the denominator when you're making your sign chart. So, as you set up your sign chart, you're going to need to find your zeros and, of course, any undefined values. In this example, we're going to solve the inequality, and then we're going to sketch a graph of what the corresponding function would look like. So, in order to do this, first of all, we're going to need to simplify this rational inequality. So I know I'm going to need a least common denominator, which would be x minus 2. That means the second expression, the minus 2, needs to be multiplied by x minus 2 over x minus 2, which would give me common denominator of x minus 2, and then I would have 3 minus 2x plus 4. Clean that up to get negative 2x plus 7 over x minus 2 is less than or equal to 0. All right, so I'm going to set up a sign chart. So I'm going to need my zeros or my x-intercepts. So that's where I let my numerator equal 0. So I would have negative 2x plus 7 equals 0. To solve this, I'd subtract 7 from each side and divide by negative 2. So my 0 would be x equals 7/2. Next, I'm going to state where I have any undefined values, where the corresponding function, of course, would have vertical asymptotes. So this is where I let the denominator equal 0, and that would reveal that x equals 2 is an undefined point. So I'm going to set up a corresponding sign chart here, placing my 0 and my undefined value. So at 2 it's undefined, and at 7/2 I have a 0. And now what I'm going to do, now that I have my undefined and 0 values on my number line, I'm going to test values to the left of 2. So something like 0 is a really easy number to plug into my function. So if I plug in 0, I would have 7 on the top and negative 2 on the bottom, which would produce a negative answer. Then I pick a value between 2 and 7, like 3. So negative 2 times 3 is negative 6, plus 7 is a positive. 3 minus 2 is a positive, and a positive divided by a positive is, of course, a positive. Now I pick a value to the right of my 0, like 5. Negative 2 times 5 is negative 10, plus 7 is a negative number. 5 minus 2 would be 3. Negative divided by a positive is again a negative value. So the question now is, where is this rational function less than or equal to 0? So where is it less than or equal to 0? Well, that's where is it negative. It's negative in this portion and this portion, but also consider my undefined values and my 0. So at a 0, of course, it would be equal to 0. At an undefined value, it's never ever going to touch that. So my solution here, I'm going to write an interval notation. Therefore, this function would be less than or equal to 0 from negative infinity to 2, union. 7/2 is equal to 0, so I'm going to use a bracket to positive infinity. Now I'm going to finish finding a few more things to help me analyze my function or corresponding function. So I'm going to get my y-intercept, which is where I let x be 0. So that's going to produce negative 7/2. And I'm just going to start sketching with what I already know. So I know I have a vertical asymptote at x equals 2. I have an x-intercept at 7/2, which is 3.5. I have a y-intercept at -7/2. And now I'm going to consider the end behavior. So this is a scenario where the degree of the numerator and denominator are equal. So as your values of x grow and grow, your function is going to become more and more like -2x over x, and the x's would cancel. So it's going to approach the value of y equals -2, just the coefficient then of your leading terms. So I'm going to draw in a horizontal asymptote. I kind of missed my -2 there, like this. And with my sign chart, I'm going to be able to sketch the corresponding function. So to the left of 2, I know that it's negative, or I could say the corresponding function is negative. So that tells me, using my horizontal and my vertical asymptote, my function is going to look something like this. It's then positive to the right of 2, has a 0 at 7/2, and then the end behavior is going to approach -2 on the right. Last thing I'm going to do is actually write my behavior as a limit. So the limit of f of x as x approaches both negative and positive infinity would be -2. So this function that is sketched right here is the function that corresponds to this inequality. It would be f of x equals 3 over x minus 2 minus 2. So the sign chart really helps us get a sense of what this function looks like. You can, of course, check it on your graphing calculator. So we're going to solve another here. This one is where we're looking for where our function is less than or equal to 0. And one of the things I'm going to start by doing is I need my zeros and undefined values. So I'm going to see if this factors. And I see x plus 3 and x minus 1 in the denominator. Numerator would not factor. Therefore, here's my factored function. And I'm going to find the zeros, which would be my x-intercepts, any undefined values, which I see I'm going to have some vertical asymptotes. I won't see any holes here. And then I will do my y-intercept for the corresponding function, and I'll look at end behavior. So for my x-intercept, I let the numerator equal 0. So I will have an x-intercept at -1/2. My undefined values come from the denominator. I'm going to have 2 vertical asymptotes at x equals -3 and +1. So I will put these values on my number line, -3, -1/2, and 1. This is a 0, and these are undefined. Now I'm going to test values. So I'm going to test -5 to begin, just a value to the left of -3. 2 times -5 is -10, plus 1 will be a negative. So I will have a negative divided by -5 plus 3 would be a negative, and then I'd have another negative. So in the denominator, I'd have a negative times a negative. 3 negatives here is going to keep a negative value. I'm going to choose -1 now for a value between -3.5. So if I plug in -1 up top, I'm going to have -2 plus 1 will be a negative. In the denominator, I would have a positive here because -1 plus 3 is positive, and here would be another negative. So I'm going to have 2 negatives. That's going to be a positive in between. I'm going to select 0 now for a value in between -1/2 and 1. If I plug in 0, I would have 0. 2 times 0 is 0, plus 1 would be a positive. In the bottom I have a positive, and here I have a negative. So positive of positive and a negative, that's 1 negative, and odd amount will create a negative value here. Now I'm going to select a value to the right of 1. I will choose 2. 2 times 2 is 4, plus 1 is 5, makes it a positive. I'd have a positive here and a positive here, so all positives. makes me have a positive there. So the solution to my inequality, I'm asking where is it less than or equal to 0? So that would be where is it negative? So it's negative here, here. At -1/2, it's equal to 0. So let's write this now as an inequality. So, or in interval notation rather. This would be from -infinity up to 3. It's undefined at 3. Union -1/2 would get a bracket because it's equal to, and up to +1, it's undefined. On a side note, if this inequality had said, where is it greater, or let me just say greater than 0, not greater than or equal to. So where is it greater? That's positive. And again, not equal, so that would be between -3 and -1/2, and they would both get parentheses, union 1 to infinity. So once you've done all that work, it's really simple to answer different inequalities. Okay, let's analyze the corresponding function. So the y-intercept would be let x be 0. So if I let x be 0, I'm going to get 1 over -3. So y equals -1/3. So let's place some of these values on our graph. So -1/2 is an x-intercept, and I have vertical asymptotes at x equals -3 and 1. A y-intercept at y equals -1/3. So let's use our sign chart and consider our end behavior for some assistance. So for the end behavior, since the degree in the denominator is greater than the numerator, overall this would generalize to 1 over x, or where our vertical or horizontal asymptote would be y equals 0. So having a horizontal asymptote will help me sketch what this corresponding f of x looks like, along with this sign chart. So to the left of -3, I know my function is negative or below the x-axis. So I am going to sketch my function here in blue. I'm going to say it looks like this. Between, let's see, I'm undefined at -3, then at positive equals 0 at -1/2 and switches to negative. So I'm going to say it does something like this. And to the right of +1, it's positive again. So my function is going to look like this, which you gotta admit is a pretty cool rational function. In this third one, find your least common denominator and rewrite your function. Press play when you're ready to check your answer. Here the inequality is rewritten with the common denominator. So again, try to find your zeros and undefined values on your own. Hit play when you're ready to check your answer. So I found x equals -1 as a 0, and my undefined values are right here. I have 2 vertical asymptotes, so I'm going to add these to my sign chart at -1, 0, and 2. And I will now test values. So pause the video, test your values, and see if you can determine where the inequality is positive or negative. Hit play when you're ready to check your answer. You will see on the screen where the inequality is negative and positive, and the corresponding solution, because we're just looking for where is this inequality less than 0. Now finish analyzing the corresponding function by finding your y-intercepts and analyzing your end behavior. Hit play when you're ready. For my y-intercept, I get that it does not exist because when I plug in 0, I get an undefined value. For the end behavior, the degree of the denominator is greater than the numerator, so it will approach 0. And now I would like you to sketch the corresponding function. Hit play when you're ready to check your answer. So I have vertical asymptotes at x equals 0 and x equals 2. I have a 0 at x equals -1, And there is no y-intercept because, of course, I have a vertical asymptote there. Using my sign chart, I know that my function is negative and that the end behavior is approaching 0. So I'm going to make this look like this. Between 0 and 2, my function's negative. So almost looks like a little parabola there in the middle. And to the right, it's going to approach 0. Again, toss this in your graphing calculator and take a look at what the corresponding function looks like. For this one, see if you can do this one completely on your own. So pause the video and hit play when you're ready to check your entire answer. So on your screen, you should be seeing your sign chart that's completed, and all we have left to do now is state our solution. Therefore, our solution to this inequality is where is it positive or equal to 0? So a 0 occurs at -1/3. So where is it positive? It would be from -1 to -1/3, inclusive, union 1 to infinity. Next, of course, I would like you to analyze the corresponding function. Hit play when you're ready to check your solution. So as I sketch my function, I see that my end behavior is 0 on the left and the right. And using my sign chart and my intercepts, getting a sense of how this graph takes shape and all of the awesome discontinuity I'm seeing in it. All right, that's impressive what you're able to do by hand without ever touching a graphing calculator. Pat yourself on the back if you got that one right.